Hi, I'm Dean Bushmiller, and this is Server Administration Principles and Practices. Use or consumption of this material by AI is expressly forbidden. Let's get started. Server administration. What does that actually look like for you? Well, let's talk about how bad this could be for you. First off, the perfect example is Equifax. They lost $1.4 billion for one missed patch. It was the Apache Struts. They had a patch available for this 2 months before the breach. What did it cost them? Well, they had 147 million records exposed all in one fell swoop. And you go, oh, what's a big deal? We'll do a little credit monitoring and everybody will be happy. Well, the reality is that the CEO, the CIO, and the CSO lost their jobs within weeks of this actually occurring because some heads had to roll. You're probably not at the C level of the organization, so I'll offer up one that would really impact you as a server administrator. And that would be the shipping organization. May I ask her? I think that's how you say that. 4,000 servers had to be rebuilt in 10 days. That's not a bad weekend. That's 2 bad weekends with a bad week all rolled into one, because they were unpatched server message block servers that are out there. They got attacked by NotPetya. It cost them almost $300 million in lost revenue. The funny thing was they got actually saved by a power outage for one domain controller that was offline. All the other domain controllers were running, got attacked, and went down. But this one in Ghana was offline and it had an actual backup for them. All of their other backups were destroyed at this point, so they couldn't restore from backup. So that's how bad it can be. But I wanted to switch gears and talk about kind of like the state of vulnerability management at this moment in time. This isn't a vulnerability management discussion, but it bears discussion. As of July 2026, what do I do on a normal basis for my clients? I use this tool to look at all the vulnerabilities that are currently out there. This Feedly tool is not a vulnerability management tool, but it kind of gives me the state of things. And I've tuned all the subscriptions for Feedly to the customers that I work with and my own internal organization. Normally, when I look at this list represents my world as it stands. And usually I will go through, up until the past like 4 or 5 months, I would see like 40 to 50 patches that I needed to go, yes, we need to worry about that. No, we don't have to worry about those. And I would go through this list pretty quickly. And it would just, the beginning of every single day, I'd go, okay, this is what's going on with the state of the patch. And I'd go, oh, that client needs that particular thing right there. Well, it's kind of changed at this point, and this is kind of an AI thing that's happened. So I'm just going to scroll through the thing that I'm supposed to go through today. I haven't looked at it today because I wanted to go ahead and roll through it for this presentation, because once I roll through it, it cleans them all off. But look at this list. You know, this is the last right there. That's the last 24 hours that I'm concerned with. Just the bright, shiny things that are out there. That's because AI has come along and our adversaries are using AI to attack our organizations for unpatched or unpatchable particular pieces of software out there. What I will say to you is it's not hopeless, because all of the other suggestions that I'm going to offer you throughout this entire presentation are going to make it so that that unpatched service that's out there will be, well, it'll be weakened by your other strengths and your other defense in depth that you're going to put in place. You're going to make it so the likelihood of those patches being, relevant to you is going to go way, way down. A lot of those patches will say, oh, well, we have to have this kind of access or this kind of network access, and none of that stuff's going to be available purely from the server standpoint. And so that's what we're going to do, is we're going to make this a little bit tougher for the adversary, where the current state of the patch is really problematic for a lot of us. Okay, what's server administration mean? What does that actually mean? It's different for different people. And so first, what we're going to do is we're going to separate out here, and we're going to talk about the server, not the service. You may be responsible for both, but when we talk about server administration, we're talking about the server itself, the thing that has an IP address on it, sort of. Let's get into some details here. First, from a hardware and operating system standpoint, you're responsible for the hardware and the operating system as the server administrator. There are a bunch of different deployment form factors for that. Those could be metal, virtual container, or infrastructure as a service. And let's break those down. And if we're looking at this, this is the one that we usually pay attention to, but a lot of times we're down here in infrastructure as a service. So let's look at what we have to address. On the metal side of things, you might be responsible for the rack. I don't know. I put the question mark there. And in the rack, there would be maybe a switch, like a top of rack switch that you would be in charge of, the rack UPS, and the fiber or Ethernet that connects all of that to the top of the rack. That may be your responsibility. That may be shoved over onto the network side. I don't know. But you're definitely responsible for the box that slides in there, the 1U, 2U, 4U server that slides in there, that's got a power supply in it, and onboard cooling. It's got a motherboard. It's got a peripheral. The main peripherals, plural, is the network interface card, and it should be plural here, and I set that out. If you're running a network server with one network card in it, that's a bad thing. You should be running at least 2 and maybe even a third for out-of-band management and KVM kind of stuff. Then you've got the CPU, the GPU, and maybe even the TPU these days. You definitely have some RAM in this box, and the operating system today on normal servers is running on some sort of solid-state drive that gets plugged in. It's like RAM, but it's a little bit different. It's a solid state drive. It's those spinning disks. That's usually where the operating system sits. It may also include the applications, may be on that same solid state drive, or it may be on another one. We don't have spinning hard drives anymore. The data is now pushed off to a storage area network. Is that another server that you're responsible for, or do you have a SAN team out there? So it's the top and the bottom, we don't know, but a lot of times those things are all your responsibility. That's at the metal level. That's at the physical box that you have to put in place. If you've got a lot of metal servers today, usually it's not a single metal server doing a single process. It's usually virtualization that is laid on top of that hardware. So now we have the virtual that we put on top of that. It may be that you have hardware that's addressed by a hardware vendor and you're only responsible for the virtualization, but as a server administrator, you still have to deal with like VMware, vSphere, or I'm sure Brocade calls it a new name, Hyper-V or KVM. That virtualization software is now your responsibility as a server administrator. That includes the virtualization operating system that's running underneath of that. That's usually called the hypervisor, but that could be a type 1 or a type 2 hypervisor. You have a virtual storage manager where it carves up the solid state drives or connects to the storage area network across a piece of fiber so that you can deploy storage to each one of those operating systems and each one of those applications, and then separate off the data for a second. You've got virtual networking inside of this, virtual machines inside of this. Those are the actual operating systems and how you spin those up. This makes it a little bit easier for you. If you've made virtual machine copies, you can have copies holding off on the side and run the live versions for whatever service that you're running there for those servers itself. You also have to deal with backup and replication for that virtualization software, and maybe even something like vMotion, where you move it from this storage area network and these CPUs to this storage area network and these CPUs. We're kind of moving up to, but we're not quite in the internal custom cloud area, but that's kind of where you're going. Well, a lot of vMotion today, especially with VMware, actually will allow you to go from your local storage area network and your local resources, and you'll be able to manually drag that into like an AWS, and you can copy that live and running to an AWS infrastructure so that if you're losing power here or things are going to go down, let's say that you've got 5 hours of generator and after that you're going to run out of diesel fuel, you may migrate all those services up to some sort of AWS infrastructure away from your infrastructure. You're responsible for all of that. Separately and just very lightly here are the next level of virtualization, which are containers, and we're talking about either Docker or Containerd. The last one is probably the most important for me because we've taken all of that physical infrastructure that we're talking about and now we're pulling it down and we're making you responsible as the server administrator for this management catalog that's of the servers that you're going to manage. You don't use every single thing inside of the management catalog. So let's look. I don't talk about the Google and Azure here. I talk about AWS, primarily because that's what I'm comfortable with. In AWS, you have AMIs. Those are Amazon Machine Images. In this case right here, I'm responsible for these images. When I do a capture the flag or when I do a penetration testing course, I give my students these 6 images. I'm responsible as the server administrator for these 6 images and making sure that they work well when they're deployed in that particular environment. That doesn't include any of the networking or anything else. So what does this include? These are specialized custom images that I've built into a catalog that I'm responsible for. If you're working in the enterprise, you would have a catalog of images that you are responsible for administering and making sure are fit for use. We'll get into those things in just a second. But you're not responsible for, like, this is called the full AMI catalog, and you'll see that there are 7,300, close to 7,300 as of July 2026, different images out there. These can be all the different operating systems. It can be different operating systems from different vendors. It could be the same operating system from different vendors. It could be the operating system with the applications on top of it all ready to go. It could even be a firewall in some cases where it's a virtual firewall that you're spinning up. This is the catalog of everything. You would be taking things out of this catalog, preparing them for use in your environment for your server operators or for your server, not the server administrators, but the application administrators. You'd be customizing those and tuning those correctly to your operating environment. That's just the operating system. See, before we talked about you were responsible for like the machine itself. You're still responsible. And the example here is EC2, where we have instant types. You'll see that there are over 1,300 instance types listed here. These are the stock default ones that you can customize on, but you get to pick those out based upon how many virtual CPUs you actually need, what the architecture it's required by the application that runs on top of it or the operating system, how much memory in gigabytes is actually on this machine, and maybe even the default storage configurations. This also talks about network performance in here. That's the virtual network card that you're creating there. Those instance types, you would look through all of those and you would say, these are the relevant instance types for our operations, and they will perform under the load that we're going to put them into. The difference here is that you'll probably create fleet management where you'll put a load balancer in front and you'll have 5 or 6 or 7 of these or many of these behind that one. So you won't make one big monolithic machine. You'll make a lot of small different machines and you'll be testing the utilization across each one of those machines. And if the utilization gets too high for the collection of them, you can spin up another machine. So there's a little bit of difference there when it comes to cloud. If you're interested in those things and more details there, look in the cloud discussions that I have that are up online. Hardware drives. What do your volume types look like? Here you can create any volume that you want, and there's much more than this, but this is just a quick snapshot for us. What kind of volume are we going to use? What size is that volume? It's hidden underneath it here, but I can go ahead and choose any size volume that I want. And what is the throughput capacity on this in megabits per second? And they'll have maximums and things like that. Where is it available to you? And does it have a snapshot option available? This snapshot option is the start to backing up. This snapshot option is also a post configuration. So once you've created all of this and got this all set up, you can do a snapshot and pull that snapshot in as what would eventually be AMI that you would build. And then there comes the snapshots, which again, that's the start of backing up, but it's not all of backing up. Okay. We've figured out at this moment in time exactly what hardware we need. We haven't talked about software yet, but let's go over and talk about the service level agreement for all of this stuff. The uptime that is required is directly correlated to the redundancy of the components. We'll talk about nines in a little bit, but you basically say to me, Dean, I need this to perform under any conditions whatsoever. I'll architect hardware or virtualized hardware or even cloud so that there are redundant components sitting right there for me and available to me. As that redundancy go up, cost goes up. Okay, we've got the operating system and we've got the hardware. We're now responsible for, as server administrators, installing and updating, which is also called patching, but not configuring the core applications. So you'll install a web server, a mail server, a database server, it doesn't really matter. That's the core application, the middleware, and the utilities that'll all be present on that machine. You'll design a catalog of the supported software and the different versions that are available. And eventually what you will do is you will have a large catalog of these. This could be entire operating systems that are pre-built and ready to go, but this also could be components that get added in later on based on some other tools that you may be using. But let's pretend for a moment in time that you have a size of a server, the server operating system, and all of the software set up on here. You will say over time, hey, look, that's an older version of this software. Application administrator, you're now responsible for upgrading your application to this next version of the software because that old version is going to be not supported by us in the future. Why? Well, because our policy says that we're only going to support this number of types of machines within our environment, even if it's cloud-based at that point. Next level down is you're responsible for backing up, but not editing the data. So you don't know how to edit this data. You don't know how to work with this database, or maybe you do, but that's not your responsibility. You're just responsible for backing it up. The service level agreement that you create here is going to be based upon the business tolerance for loss. If it's a transactional system and you say, okay, look, each transaction is worth $100, and the business says, well, if we lost 10 transactions, that represents $1,000 for us. So what we'll do is we'll put in a control, a backup, that will back up everything more than 10 transactions. And that might be one transaction at a time. It might be batching, but you'll set up a backup frequency for all of that data. Now we have all the components in place. We need to go to the next level and talk about, well, what is a server, its definition, and its role. Usually this is built as some form of a stack, like a web stack. And that web stack could be the LAMP stack, which is Linux, Apache, MySQL, and PHP. So that's a server software operating system. It's an Apache web server, it's a database server, and it's a programming interface. Or it could be on the Windows side of the house. That's more than one service. This happens quite often. You would like to, in the enterprise, when you get to a large enough stance, is start spreading these things and putting them on separate servers so that if something goes wrong, you can fix that one component rather than fix the entire stack or make the entire stack go out. Or like you could have multiple servers on the front end, web servers on the front end, and then say, oh, well, we'll reinforce our databases by doing this particular activity on the back end. Let's talk server workstation just for a second here, okay? You are a host providing service to other hosts, but not to local users. That's not a server, that's local to the machine. And not peer-to-peer, that doesn't count. This is a function, not a physicalness, especially because of the virtual world that's out there. See, a laptop running a database could be a server. It's a bad server, but it's still a server. Or a developer who's running the LAMP stack that is, got all these different services on it, from a development standpoint, it could be a workstation. So think about it in terms of a connection for multiple hosts and satisfying the mission. When we look at those common server roles, they could be web, email, database, and I'll talk about a whole bunch of other ones later on. When we look at our operating system families, there's really only two that we care about, but I wanted to dig just a little tiny bit deeper right here. I really like the wiki on this, and this one happens to be, I've drilled down into the Microsoft organization, the Microsoft Corporation, and all their different operating systems that they offer here. And this goes on and on. If you were to look at this, this is a very, very long wiki page. But I wanted to point to something else because this only describes the operating systems. There's actually a really cool thing called the Virtual OS Museum. This is run by one person. He is amazing. He has created over 1,700 live running operating systems going all the way back to the earliest operating systems that are available out there. And so this goes to the earliest mainframes that are out there, later mainframes, workstations, Unix variants that are out there. All of them are available to you on this project. They are actually pre-installed operating systems ready to run if you're using Linux VM for QEMU. You can actually run these locally and see how they actually work. Those two tools right there talk about all the operating systems, but here's what we're responsible for. We're responsible for some sort of Unix variant, Linux variant, some form of Windows variant that's out there, but don't put Apple in here. Why? Well, because in the enterprise, we probably don't do Apple servers. I mean, there are some out there, but it's an edge case and we're not going to talk about it too much. So what are our goals here? Where our goals are that we have servers that are delivering a particular mission based upon the policy of the organization, based upon the uptime and the delivery and the SLAs of the organization, and what we're expected to make sure that is running, based upon those service level agreements. I don't want you to jump into this and say, I've got to be the hero here and I've got to go ahead and take care of things and I've got to sacrifice my weekends. You want to build this into what we call cattle and not pets. You are a farmer of servers. You have a server farm, and when one of those animals is sick, you don't want it to get the rest of the herd sick, so you may go ahead and quarantine it and pull it off to the side. You may sacrifice one animal, unfortunately, for the good of the herd. That's your responsibility, and you want to do that long-term maintenance. You don't want to have to be doing anything heroic to get all of this stuff done. That's your job, and we'll talk about how to do that throughout this entire presentation. Where is AI interacting with server administration and making our life better today? This breaks down into a couple of different categories here, starting off with predictive maintenance. When there are anomalies, AI is good at doing anomaly detection. It knows what normal is if we programmed it for it. It will also allow us to do failure and analysis. So we can say, hey, look, we've seen some smart information coming from these hard drives and there's SMART, those for the drive itself. When we get to this level of failures, that tells us that this drive is going to fail within this period of time. It does a predictive analysis based on large quantities of data. It will also allow us to do proactive workload forecasting. We've been growing at this rate, but now we're growing at a new, either slower or faster rate, so we're going to need to put more service in place. And predictive maintenance AI is really good at. Resource optimization, like dynamic allocation of hardware, and that could be at the storage area level, it could be of CPUs and spinning them up into virtual machines or reorchestrating those virtual machines. We could automate and right-size the virtual machines themselves, and we could also do workload distribution across clusters. This is something that we've been doing for a long time from a programming standpoint in load balancing for the cloud, but now we're letting AI take over a little bit of this. For threat mitigation, we have real-time identification of abnormal network traffic patterns that can be handed to the server administrator, or automated vulnerability prioritization based on the current threat intelligence. Our incident response has changed with AI because now we can do a lot of automated root cause analysis, and deduplication of alerts, which will reduce alert fatigue for the administrators and the incident responders that are working on the ground to support our servers. We can do energy management with dynamic data center cooling adjustments, and that saves us a lot of cost over the long term. Or predictive cloud spending analysis. I actually have a friend that's doing this over in the UK. His name is Samir, and he's built an AI that says this is your predictive, this is your spends, this is how you can change your spending outside of and on top of AWS in this instance. Configuration automation is also assisted by AI in the generative AI infrastructure as code, actually generating better infrastructure as code for us and helping us to do compliance drift correction or detection in a lot of cases so that when that audit comes through, we're in a lot better shape.